The global race for clean energy has reached a turning point, and it is not coming from wind farms, solar arrays, or billion-dollar fusion machines. It is coming from a compact, fast neutron molten salt reactor designed by a French startup that did not exist just 2 years ago. The reactor is called Stellarium, and according to its creators, it can do something no commercial reactor has ever achieved. It can destroy more nuclear waste than it produces. And now, one of the biggest data center operators in the world, Equinix, has officially reserved the first 500 megawatts of power from this system. This technology is being positioned as the energy backbone for the next era of AI, where data centers consume more electricity than entire nations. Stellarium is not just another reactor proposal, it is the first fast neutron molten salt reactor engineered from the ground up for real industrial deployment, real clients, and real electricity production for AI infrastructure. It represents a new direction for Europe, which has been struggling with rising power demand, overstretched grids, and an increasing dependence on imported gas. At the heart of Stellarium is a radically different fuel system. Instead of solid uranium rods, the core uses liquid chloride salt that contains the fuel within it. Because the fuel is already molten, the reactor cannot melt down. It operates at atmospheric pressure, which removes the risk of catastrophic pressure failures, and the liquid core allows natural convection to provide passive cooling. Stellaria says this design offers 4 physical containment barriers, an additional layer compared to most reactors in operation today. The entire reactor fits underground and occupies only 4 cubic meters, yet a single unit can power a city of 400,000 people for decades at a time. What makes Stellarium truly disruptive is the fuel cycle. It is a fast neutron system, which means it can consume materials that today are considered long-term nuclear waste. That includes plutonium, MOX fuel, minor actinides, and even thorium. Because the system runs on a closed fuel cycle, the same material can be reused over and over, and waste from older reactors can be repurposed as fuel. Stellaria believes this reactor can be the first commercial system to eliminate more long-lived waste than it creates, a milestone that countries like the United States, Russia, China, and Japan have been chasing for decades. Equinix involvement is what transforms this from a scientific experiment into a real-world energy project. Data centers powering AI are already straining grids in Europe, the United States, and Asia. The International Energy Agency estimates a 4% annual increase in global electricity demand through 2027, driven mainly by artificial intelligence, electrification, and industrial recovery. Existing grids cannot keep up, and renewable energy alone cannot supply non-stop power to AI clusters. By reserving 500 megawatts of future power from Stellarium, Equinix is making a statement. AI needs clean, constant energy, and this reactor may be the first scalable solution designed specifically for that world. Stellarium's underground installation is another advantage for data centers. The design does not require large exclusion zones, does not depend on high-pressure systems, and does not face the same cooling limitations as older reactor designs. Because the fuel is liquid, it can react to load variations instantly, making it ideal for AI workloads that spike unpredictably. And with a reactor that can run uninterrupted for 20 years without refueling, Equinix can build data centers with guaranteed power availability that is independent of weather, geopolitics, or supply chain instability. Behind the scenes, Stellaria has moved quickly. The startup was founded in 2023 as a spin-out from France's National Research Agency, CEA, and Schneider Electric. In July 2025, they raised 23 million euros in funding. Their plan is clear. First fission reaction by 2029, followed by commercial deployment in 2035. This is one of the most aggressive reactor timelines in Europe, but the design deliberately avoids excessive innovation. Instead, Stellarium uses proven fast neutron physics, molten salt technology with decades of research behind it, and engineering choices that accelerate certification rather than slow it down. The The strategic implications are enormous. If stellarium succeeds, Europe gains a sovereign energy technology that can support its industrial growth without relying on fossil fuels or foreign suppliers. If it fails, Europe continues down a path of energy shortages, grid limitations, and rising dependence on external nuclear power. The fact that Equinix has chosen to place a significant power reservation this early shows how urgent the industry sees the problem and how credible the solution appears. Stellarium also unlocks a new model for nuclear deployment: small, modular, waste consuming reactors that can be installed directly at industrial sites, powering AI clusters, steel plants, chip fabs, hydrogen facilities, and entire cities. This model bypasses the decade long construction delays of traditional nuclear plants and opens the possibility of multiple reactors operating in parallel under a unified, low risk architecture. The world is entering an era where clean energy is no longer optional. AI will not grow without stable electricity. Industry will not modernize without reliable power, and nations will not remain competitive if they cannot support the next generation of technological expansion. Stellarium is presenting an answer that is compact, scalable, and fundamentally different from the energy systems of the past century. It is too early to say whether the reactor will achieve its goal of eliminating long-lived nuclear waste at commercial scale. It is too early to declare it the backbone of European AI infrastructure, but it is clear that this project signals a shift. Nuclear innovation is not just returning, it is accelerating, and it is now being shaped by the demands of artificial intelligence. The next decade will determine whether this French design becomes a global standard or remains an ambitious experiment. For now, Stellarium stands as one of the most promising attempts to reinvent nuclear power for the world that AI is building. If you found this deep dive powerful and eye-opening, make sure you like this video, subscribe to Dezen, and share your thoughts in the comments. Your support allows us to uncover the breakthroughs shaping the future of energy, AI, and the world ahead.